So this is Dr. Kavita Singh, Associate Professor, Department of Civil Engineering in Institute of Aeronautical Engineering. So today as we know, we have already discussed about the structures of different types of rocks. Like we have discussed about metamorphic, we have discussed about sedimentary, we have discussed about igneous rocks. So now in today's lecture, we are going to discuss about the structural geology. So basically, what is the structural geology? What kind of structure the entire geology is having. So that we'll be discussing today. So let us start this lecture on structural geology. So first of all, let us understand what is a structural geology. So structural geology is the study of three-dimensional distribution of rocks, units, and the forces that cause deformation of the earth crust. So basically, it's a study of 3D distribution of rocks, 3D distribution of rock units. So in geology, first of all, we study about the rocks and minerals. So basically, its distribution, its alignment, and the texture and the structure, that all we study in the structural geology. And deformation of the earth process of the earth crust, this all we study in the structural geology. So it focuses on the understanding. How rocks have been altered. So it will focus basically on the rocks which is altered. Altered means in a day by day or a year by year or millions of years ago, let us say, every day the process altered means the weathering of rocks. Okay, the weathering of rocks. I hope you remember about in the previous lectures we have already discussed about weathering of rock. So what is the weathering of rock here? What do you mean by weathering of rock? So rock is weathered every time, every moment. So as we know, weathering of rock is the process of what? It's a process of weathering of rock is a process of the existing rock. Okay, existing rocks will be weathered. Okay, weathered in sense it will be weathered means the upper layer of the rock will be removed, or it will break into powder. Okay, into pieces or powder due to what? Due to heat and pressure. Okay, so already heat and pressure, as well as sometimes we see the temperature is fluctuating, it's very dynamic. So you have the weathers are like, sometimes it is a cold condition, you have a hot conditions. In that conditions, the rocks will contract and it will just break down into pieces, and that pieces will be carried away by the water or wind, and it will settle again in the other locations. So weathering of rock, always the rocks are altered. So continuous process this is. So when the rock is very weak, it is weathered very fastly. So slowly when you try to build a structure on a that kind of rock where the rock is having a weak structure, or else it is weathering due to the weather conditions, it is continuously getting eroded. So in that case, the failure chances will be more. So in the previous lectures, if you remember, we have already discussed about these things, like the buildings or the structures which are constructed on these kind of rocks, or the dams which are constructed on these kind of rocks, the failure chances were more, and the dams or the structures are already failed due to this kind of altered over time. So altered over time due to the tectonic forces, and how this deformation influence the earth's surface and features. Now what is deformation basically? So the process by which rock change shapes. Okay, deformation is very important, and it continuously happens. So the process by which rocks change shape under stress. Change shape under stress means, so whether stress conditions, when the temperature is high or low, in that kind of condition, this can be elastic or plastic permanent. So elastic means recoverable. When it is elastic, then we can recover it, or a plastic means permanently it will change its shape. So that we call it as deformation. When a rock is in a normal form, it may change its shapes due to the deformation process, either due to the heat and pressure conditions. Now strain. And even with the tectonic movements, as we know, the tectonic movements occurs time to time, and your plate boundaries are moving continuously. So when they collide with each other, these kind of conditions happens. The deformation occurs on the surface of the ground. So now here we have a strain. So the strain is a change in shape. Strain is a change in shape or volume that results from the deformation, often categorized into different types. Example, extension, compression, and shear. So it's a shape or volume that results from the deformation, often categorized into a different types of extension or compression or shear, and stresses the force per unit area exerted. What is the stress here? The force per unit area is exerted on the rock. So per unit area, how much force is applied or exerted on the rock, it can cause deformation. When it exceeds the rock strength, stress can be compressive, tensional, or shear. So it can cause a deformation process, and when it exceeds the rock strength, the stress can be compressive and the tensional or the shear conditions. Now deformation refers to change in shape or size of material or structure due to applied forces. So the forces which it applies, the forces is due to the tectonic activities and due to the temperature changes or other external influences here. Now we have a types of deformation. What are the different types of deformation here? So we have a elastic deformation, plastic deformation, viscoelastic deformation. Okay, so and under this we have deformation refers to, these are the different types. So what is elastic deformation? Let us see here. So temporary deformation where the material returns to its original shape, right? So when the deformation is taking place, so this will be temporary kind of deformation. So it will change its shape and suddenly it will come back to its original shape after some time, after the load is removed. So once the load is there, the in a pressure conditions like a elastic, when you apply a load on the elastic, it will be pressurized and it will compress. Okay, so as we remove the load, so it will come back to its original position, right? Elastic deformation. Permanent deformation where material does not return to its original shape. So plastic deformation is a permanent deformation where the material does not return to its original shape and after the load is removed. So viscoelastic deformation is time dependent deformation where the material exhibits both elastic and viscous behavior, like common in polymers and some metals are at high temperature. So viscoelastic is what? So both kind of behavior it has. It has a exhibits both elastic behavior and it has a viscous behavior. Now in a common polymers and some metals at the high temperatures. So it has both kind of conditions it will work. Okay, so viscoelastic or elastic or plastic. So these three types of deformation happens, either elastic or plastic. Elastic means it will come back to its position again, but plastic is a permanent kind of deformation. It will not come back to its position. It will permanently change its shape. Okay, so permanent deformation where the material does not return to its original shape and after loading is removed. So when some load is applied to the structure or any kind of material, when you apply the load, so it will some kind of material will just compress and it will remain as it is. So that kind of behavior we call it as plastic deformation. Okay, plastic deformation. And here we call it as elastic deformation. Elastic deformation, it has a facility of at least coming back to its original position, right? Viscoelastic deformation, time dependent deformation where the material exhibits both elastic and viscous behavior. So in this you will be finding both kind of conditions, either elastic or plastic both. Okay, so in structural geology, so these kind of structures we see basically we have, so here you can see here in this the strains deformation process, as we know deformation. Then we have second thing is folds. So in structural geology, basically when the load is applied, when it goes through a heat and pressure conditions, or the tectonic activities are continuously in the process, or when the plate movements, the plate boundaries are colliding to each other, then what happens in between collision conditions, there is a chance of folding or faulting, or the ground subsidence, it will go up, down, colliding. These all kinds of deformation will take place in this. So like folds happens, bends in a layer rock typically caused by a compression stress. Examples include anticlines, upward folds, synclines, downward folds. These all folds you can see here. So these are the due to the pressure applied to the rock. Okay. So this is the type of deformation it has been taken here. So now if it is elastic, it will come back to its original place, okay, original position. But here if it is a plastic kind of deformation, it will be, so these kind of folds will be formed in the layers, okay. These are all, you can see here it's a like layer wise the folds are formed. Now after a fold you have a faults, okay. So this is also very important kind of structure which is formed due to this deformation process, where we call it as faults. So faults are the fractures in the earth crust. So you can see here we have three images here, right? Three images here. So one image you can see it is showing as reverse fault. Okay, fault means it's a fault line which has a breakage between the ground and both two grounds. Okay, so it will just make a crack here where you can see the ground is divided into two parts. So this kind of fault we call it as reverse fault. So fault is a fracture in the earth crust. So it is basically kind of a fracture. The original position it has to be here, but you can see it is going down, right? It is going down here, and here it is coming up, okay, and here it is sliding. In this condition it is sliding. So fractures in the earth crust along with the movement and occurred faults can be normal, extension, reverse, compression, or a strike shear. So this kind of fault where you can see here, so reverse kind of fault means the faults which has a reverse means it will go down, okay. So here you can see the normal fault is suddenly this will go down, this will be up, and here in this strike slip fault is like sliding one side here, one side here, okay. These faults will occur at the time of the when the plate boundaries are, or plate tectonic activities. Now what is plate tectonic activities? What do you mean by plate tectonic activities? Yes, plate tectonic activities are the plate boundaries. As we know, the entire earth is formed by the plate boundaries, so it is moving every movement, okay. So when it collides the one boundary, when this, suppose this is the boundary, so this boundary when it collides with the other boundary, okay, this type of boundaries are there. So when it collides with the other boundary, so what happens at that time, the earthquake occurs. So due to the earthquakes, collision and all, these kind of faults will occur on the earth crust. So fault is basically kind of fracture. It fractures the earth surface into different shapes, okay. So we have kind of reverse fault, we have a normal fault, we have a strike slip fault. So again, one more type of structure here we have in the structural geology, that is joint. So this is also formed by the deformation process, okay, deformation process. There you can see your joints, cracks in rocks where there has been no movement, often related to tensional stress. These kind of joints are basically where there has been no movement. When there is a movement, a process is not there, there is no tectonic movement activities, and here the rocks are joined to each other, and there is no, because of no movement, it remains as it is. So it looks like a joints in the one layer and the other layer, okay. So these are the cracks in the rocks basically, where there has been no movement and often related to the tensional kind of stress. Then we have mountain building. So mountain building is also one kind of structures in the structural geology here. So mountain building is a process by which tectonic forces push up the earth crust. So the forces, that process which tectonic forces push up. So basically, what is a mountain? Mountain is a uplifted area. The this is due to the, what you can say, due to the tectonic activities wherever the fault zone and the what you can say, fault zone is there. Wherever the earthquake zones are there, there only we can find the mountain buildings. So wherever the tectonic forces will be pushing up, tectonic forces will be pushing up the earth crust from mountains, typically through the compression forces at the convergent boundaries. So wherever you have a convergent boundary means, suppose this is a, for example, this is the earth surface. Okay, so in this we'll be having a boundaries like this. Okay, so these are all called as convergent boundaries. Convergent boundaries. These boundaries are moving apart or colliding to each other. So it is continuously floating, like it will collide either with this boundary, may collide with this may collide with this. So once if it collides, so wherever these boundaries are there, okay, these boundaries we call it as convergent boundaries. So wherever you have these kind of boundaries, there the tectonic forces will act. Okay, tectonic forces will act. So what is tectonic forces? Tectonic forces, due to tectonic forces, the earthquake may occur. Okay, so tectonic forces means colliding of one plate. Suppose this is plate 1, suppose this is plate 2. Okay, so when the plate 1 collides with plate 2, so here we have this boundary, we call it as, basically we call it as tectonic boundary. Okay, tectonic boundary, or we call it as convergent boundary. So here itself you may find there is a earthquake zone. Okay, this zone will be under earthquake zone. So on this layer itself, in this boundary only, you will find mountain, right? The building of the mountain you will find here. So what is the proof of this? How we can say that this line itself, the convergent boundary itself, is having the mountain building? Because in India you see, so you have 5 zones, right? So basically we have the total India is divided into 5 zones. So we have, suppose zone 2, zone 3, zone 4, and we have zone 5. Okay, so zone 5, suppose this is our India. Okay, if this is our India, so in this India you may see zone 4 and 5. Zone 4 and 5, this entire region has what? Earthquake zone. Why it has an earthquake zone? Because in this region itself these kind of convergent boundaries are present on the earth surface. So whenever one plate collides with the other plate, this boundary which is available here, there itself the formation of the mountain will fall. So that particular region where the earthquake occurs more, where the convergent boundaries are more. Okay, when one boundary where it is joining to the other boundary, so that particular region itself, it has a mountain boundaries. Okay, so the proof is that is like Himalayan regions in India, you will find in the zone 4 and 5. Okay, zone 4 and 5. So why zone 4 and 5 is the most vulnerable region for the earthquakes. Now zone 4 and 5 comes under this the northern part of India, the Himalayan regions, the entire northeastern state. This all comes under the zone 4 or 5, and there itself we have a convergent boundary. Okay, where the tectonic forces will act. Okay, so once the tectonic forces will act, the one boundary will collide to the other boundary. So there itself you will see the mountains will be present on the earth surface, no other regions. So here we don't have more mountains in the central part of India. You may see in the eastern part somewhat, in the western part somewhat, in these regions only where the zone 4 and 5 occurs. So there only the mountains. Here in the western Ghats and eastern Ghats also, they appear in the zone 4 and 5 itself. So that's why these regions will contain mountains here. Other regions, if you see, there the mountains will not appear. So the building of the mountain in the structural geology, it will take place. Where it will take place? In the tectonic region itself. It will push up the earth crust to form the mountain, typically through the compression forces. Typically through the compression forces will act. Compression forces will act at the convergent boundaries. So here, as I told you, these are all convergent boundaries. Convergent boundaries. Okay. So here in this boundaries, the plates will be moving. Either it will collide to each other, or it will collide to each other, or it will move far, as I showed you here in this image. So while collision, okay, while the tectonic forces are occurring, these kind of faults will occur. The earthquake will occur. Definitely the earth surface will slide, just slide. So there is a fracture which occur in the earth crust. Okay. And we have the geological maps and cross sections. These are the tools used by the structural geologists to represent the distribution of rock layers, faults, and other geological structures in the given area. So these geological maps will help us to, we use this kind of maps as a tool. Basically, we use these maps as a tool by the structural geologist. So they will represent the distribution of rock layers. The maps will help us to just get to know about the distribution of the rock layers and folds and faults and the other geological structures in a given area, whichever area we are going to display the information. So geological maps will help us to get to know about the regions where it has the fold and fault regions or cross sections. So that particular region. So why this kind of structural geology is important to study? First of all, why it is important to study? So as we know, as we are discussing here, there are different zones which will totally affect the surface of the earth. It will totally affect the surface of the earth. So we are just constructing so many buildings on any kind of surface. So if the surface comes under the earthquake zone, or it comes under the tectonic forces region, okay, so wherever the tectonic forces, or it comes under the plate boundary region, so wherever it comes under these kind of regions, and when we try to construct a house, so there is a lot of chance of failure. So as we know, in India also, the northern part, the Himalayan regions, and the western part of India and the eastern part of India, there the houses are constructed with a earthquake resistant building. Like before itself, they will try to construct the building in a resistant way, because definitely it's a region under zone in 5, so it's a vulnerable region, and the people who are staying over there, so they are staying on the surface of the earth under that where you have a convergent zone, okay, convergent boundary. It can move anytime, it can move apart. There is a lot of chances of fault formation, lot of chances of faults formation, and suddenly the mountain regions formation and all. So due to that, these regions comes under the vulnerable zone. So here the geologist will use, they will use the cross-section maps, they will use the geological maps. When you check a geological maps, it will show you the main areas which is suitable for the construction works. So to select a site, okay, site selection is done basically based on the geological maps and cross-section maps. So which will tell you that whether this kind of area, the particular land, it is under the danger zone, or this kind of land which is under a safest zone, or comes under zone 4 or 5, which will help us in future to construct or decide the type of houses to be constructed over there, which can save the life of the people and save the life and property of the people, which can help us in the sustainable development of the future. Okay, so this structural geology is very much important. First of all, to know about the different types of rocks and their structure, And the most important part here is, as we have already discussed, about the weathering of the rock. Weathering of the rock is a very important part here, because weathering of the rock is only totally it is dependent on the type of the rock. If the type of the rock is totally weathered at a high speed, then the problem here is the persons who are staying, the people who are staying over there, they face lot of issues related to the failures of the construction. So that's why, first of all, before selecting the site and before selecting the type of the house going to be constructed, there we have to go through the zone area first of all, and we have to just contact with the geologist to know about the type of the land and know about the type of the structure underground. Okay, because once the house is constructed over the surface of the earth, and later when an earthquake occurs, there is a chances of failure over there. That's why before they use, people also generally, if they don't know, if they are not even a unknown persons also, they just refer these geological maps to find out the areas where it can be used as a tool. Okay, it can be used as a tool to know about the structures of the distribution of the rock layer, what kind of rock layer, as we have seen in the previous this thing. Like you can see, when you go through the map, it will tell you at least basically this area comes under joint region, or this area comes under fault region. Okay, fault region, or something like fold region. So these kind, under beneath the earth surface, what kind of layers are formed, that will help us with the study of this geological maps, and with the help of the geologist also we can get to know. Okay, so the distribution of rock layers, folds, faults, and other geological structure in the given area. So structural geology is very important in the engineering geology to know about the proper site selections. Okay, so that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.